Okay, here in lesson 2A, our two learning targets are determine a probability model for a chance process, and then learning target 4, use the complement rule and the addition rule for mutually exclusive events. So in that, we'll actually be finding some probabilities. Okay, so a number of just vocabulary things we need to take care of. Number one, what is a sample space? Well, sample space is the set of all possible outcomes. So if I'm flipping a coin, my sample space would be two things, heads and tails. And there I would have listed my entire sample space. If I was rolling a dice, my sample space would be 1, 2, 3, 4, 5, 6, and that would be all of my possible outcomes. And so it can be pretty simple, or it can actually be rather large if I have a large sample space. Complement. Basically, this is the opposite you can think of. So if I had the probability of event A happening, okay, let's say that's, I don't know, 0.9. Okay, so just know that this is not P of A, it's not like a function notation thing, this is a probability notation. So probability that event A happens is 0.9. Well, the complement of A, so we would say A complement, would simply be 1 minus the probability of A. It's basically saying, what is the probability that A doesn't happen? Hence the opposite. And so 1 minus the probability of A, in this case, would be like 1 minus 0.9, which would be 0.1. So if there's a 0.9%, or I guess if there's a 9%, 90% chance that it happens, there's a 10% chance that it won't happen. All right, a probability model. Well, that is a description of a chance process so essentially a probability type situation that includes, so it's going to include two things. It's going to include the sample space and the probabilities for pretty much everything. Okay, so the next big thing, and this is probably the heart of today's lesson, and that is mutually exclusive events. Disjoint events would be a synonym for that. And basically, we're talking about no common outcomes. So maybe you think of it like this. If I was rolling a dice, and here's my sample space, 1, 2, 3, 4, 5, 6. And I said, what's the probability of getting a 3 or an even number? Well, are there any 3s that are even numbers or even numbers that are 3? No. So those are what are known as mutually exclusive events. There's no common outcomes. As opposed to saying maybe something like, what's the probability of getting a 3 or an odd number? Well, 3 is an odd number, and so they have something that overlaps. And so those are not mutually exclusive. Let's see, an event. Basically, an event is just what you're trying to find the probability of. But, formally we'll say it's a collection of outcomes. All right, and then finally, the addition rule is the big theme for today, and it deals with mutually exclusive events. And so basically it says this: if two events are mutually exclusive, Okay, so like getting a 3 or an even number. Then we add, so if you can add, you're going to do pretty good today. And then we add the two probabilities to get the probability that they both occur. Right, so really I'd say probably this right here and this right here are the big themes that we need to talk about today. All right, so some examples. So here we've got a case where we've got different types of dice, and we've got a 4-sided dice that has 1, 2, 3, and 4. So it says list the sample space for rolling the die twice, or 2 dice. And so here, just real simply say, all right, we could get 1 and then a 1 and then a 2, 3, 1, 4. So that takes care of all the ones where you got 1 right off the bat. And then we could say 2, 1, 2, 2, 2, 3, 2, 4. And that takes care of all the ones that start with a 2. And then 3, 1. So it takes care of all the ones with a 3. And then 4, 4, 1, 4, 2, 4, 3, and 4, 4. Okay, so there is our sample space. And then here, this is a lot of words for something that's pretty simple, but it says, what is the assignment of probabilities to outcomes in this space? They all have a 1 in 16 chance. So they all have one positive outcome, the first 3, then the 1, and then there's 16 of them, so 1 out of 16. All right, and then 41 down here says refer to 39, obviously that's there. Define event A as the sum is 5. Find the probability of A. Okay, well the probability of A, that I have a sum of 5, well, looks like I've got this would add up to 5, this would add up to 5, this one, and this one would add up to 5.